So, this is from the American branch of Hogwarts. I have my charms exam tomorrow, and I have to turn in a video of a water repellent spell. So, I've got my owl here to help me, and I guess we'll hope for the best. So, I have my wand, and I think the way this works is you point it at it, and you have to do a swish and flick. Alright, don't forget the swish and flick. Okay, so once you got that down, then you say, agua repello. Got it? Okay. Agua repello. Moment of truth. So then you just pour some water on your fabric, and hopefully if it works, it won't be absorbed, which it looks like it's not. And then here we have regular fabric that hasn't been treated with anything or put charms on. And you can see that this one, right here, the normal one, is absorbing the water. So it didn't work. But this one, the one with the water spell, see, I can move it and the water doesn't get absorbed. Magic! Okay, so it wasn't actually magic, but the chemistry behind the actual reaction could be considered magical by some. First, you need to understand thermodynamics, okay? So thermodynamics is the combination of mechanical energy and heat and how they work together to predict different parts of a chemical reaction. Now, the three main parts that we're going to study right now are enthalpy, entropy, and Gibbs free energy. Now, enthalpy is going to be the total amount of heat, energy just energy per se in the products minus the total amount of energy in the reactants, okay? So that's going to be notated by delta H. And then entropy is the amount of disorder in a substance, okay? So that's going to be notated by delta S. And then we have Gibbs free energy, which is the energy associated with a chemical reaction that is capable of doing work, okay? Now, in order for a reaction to be spontaneous, the Gibbs free energy has to be negative. It can't equal 0 or be above 0 because then it's just not going to happen. So, for this experiment, we had a hydrophobic substance, okay? And we took one cloth and we sprayed it and we put it all on there. And we had the other cloth and nothing was done to it. When we poured the water on, the water was absorbed by the one that didn't have anything done to it. And the one that was sprayed with hydrophobic, it didn't absorb the water. So the question is, why? Okay, so hydrophobic substances, when they react with water, it's an endothermic reaction because the hydrogen bonds in the water molecules are broken. Therefore, the heat is released into the system, making it endothermic. Because it's endothermic, you're going to have a very, very small enthalpy. Now, this doesn't mean every endothermic reaction has a small enthalpy. It just means for hydrophobic reactions, they have a small entropy. They have a small enthalpy. Now, your entropy is going to be negative because when the hydrogen bonds in the water molecules are broken, they don't react with anything, right? So then the water molecules form around the hydrophobic substance and they create an ice-like cage, which makes it more ordered. Therefore, your amount of disorder is going to decrease and it's negative. So when you plug these into the equation right here, you have the Gibbs free energy equals the amount of entropy minus the temperature times the entropy, okay? And when you plug that all in, these three things right here, you're going to get a positive Gibbs free energy, and that means it's not going to be a spontaneous reaction. So the reason why the water wasn't absorbed by the cloth that was treated with the hydrophobic substance is because it is not a spontaneous reaction. Thanks for watching.